way to determine whether two quantities are proportional is to graph the quantities on the coordinate plane. If the graph of the two quantities is a straight line that goes through the origin, then the two quantities are proportional. That's really important. It's a straight line and it goes through the origin. What is the origin? We know that the origin is what? 0, 0. Then the two quantities are proportional. So the cost of renting center A and center B for a party is shown on the graph below. Okay, so let's move this up just a little bit. So we've got straight lines, don't we? Okay. Center B is the red line. Center A is the blue line. Which one of these goes through the origin? Center B. So center B is a straight line that goes through the origin, so it is going to be proportional. Is it proportional to center A? So it says for center A, the rate is not constant. So the relationship between the cost and the number of guests is non-proportional. Notice that the graph for center A is a straight line that does not pass through the origin. For center B, the rate is constant. You can have a constant rate as long as you multiply. When you add, subtract, and divide, when we're dividing, remember I said it's like multiplying a fraction. So you can never do it when you're adding or subtracting to have something constant. It's always multiplying. So it says, so the relationship between the cost and the number of guests for center B is proportional. Notice that the graph for center B is a straight line that does pass through the origin. So when I said we're going to graph proportional relationships using these graphs, it's not as difficult as we come. When we're doing this, we also have to be able to use it in a chart. So for example, up here, determine whether each relationship is proportional by graphing on the coordinate plane. So what you have to do in this lesson is you have to take this and graph it. What did, in our notes from the other day, what did I say the top one was always going to be? Was it going to be Y or was it going to be X? So you always need to make sure, okay, this is my X, this is my Y. Okay? And some of you might have difficulty reading, like, so these are my coordinates. So this first coordinate would be 0, 0. This second, the coordinates would be what? 1 and 5. Then 2, 10, 3, 15, 4, 20, correct? Okay? Then you're going to graph it on here. 0, 0 is right here. Over 1 up to 5. Then over 2 up to 10. Then over 3 up to 15. Over 4 up to 20. Ask yourself, does it create a straight line? Does it go through the origin? Okay, so it is proportional. Don't forget about how we learned about it the other day too. It's always Y over X. So then this is my Y. So 0 over 0. You can never really use that one. Don't ever start with 0, 0, okay? Because it's always going to be 0. But then I've got 5 over 1, which is, then I have 10 over 2, which is, then I have 15 over 3, which is, 5 is my excellent. 5 is your constant because Y over X is my K. K equals the constant. To write it as an equation, I would write Y equals, what's my K? 5 times, does that make sense? They are not going to ask you to write this, but I am going to ask you to write it today. Okay, I want you to get used to finding the constant also and putting it into the equation. Okay, so every single time, if it's proportional, or show me that it's not proportional. All right? So if I would say the distance, so in 1 second, they traveled 5 meters. So for every second, it is 5 meters. So it would be, the unit rate would be 5 per unit. Oh, look, before I even look down at this, look what it said. The ratios are constant. Did we not find it already? But by looking at the chart. Let's look at B. A candle is 20 centimeters tall. It burns at a rate of 2 centimeters per hour. Is the height of the candle proportional to the number of hours it burns? It says make a table to find the height of the candle after 0, 1, 2, 3, and 4 minutes. They already created the chart for you, but you have to learn to create the chart yourself. Okay? So the candle's 20 centimeters tall. It burns at a rate of 2 centimeters per hour. Okay? So to figure out the graph, how would I do it? Y equals 2 centimeters per hour is my constant. So if I start, I can't really have a constant, can I? Because I start at 20 centimeters, right? After 1 hour, I'm down 2. That's after 1 hour. After 2 hours, I'm down 2 more. What operation am I doing? So can I ever have something be proportional? No. When you're subtracting, nothing can ever be proportional. How can it be proportional? Only if I'm doing what? Multiplying. Because do you see what I started with? I started with y equals, how could I do that? Well, it really would be y equals 20 minus 2. So it's really my x minus the 20 minus 2. Whatever my x is minus 2. So it doesn't work out. So, and then when we graphed it, does it go through the origin? It is a straight line, but if it doesn't go through the origin, it is not going to be proportional. And the ratios are not constant. So they give us the chart. Determine whether the cost is proportional to the number of items in each relationship by graphing the coordinate plane. Explain. Okay. I want you guys to start by doing it the other way, and I will get out a stamp. You need to have a blank piece of paper out. I'm going to come around and put a couple stamps on your paper that is a stamp of a coordinate plane that you will use. In the meantime, you're going to say that this is my x, this is my y, and I'm going to do y over x. Does that make sense? So then my first one would be 6 over 2, which equals 3. And I want you to keep going, at least a couple on those. I have dry erase coordinate planes that you can draw the graph on your coordinate plane. Well, you have a piece of paper and you have a pen that you can get working. And then you need to go around and hit that you're unprepared and you need to get a marker. You need a marker, go get unprepared and get a marker. You guys, I should see your markers out on your desk. We use it every day. Okay, I'm gonna have you guys freeze because it looks like everybody's at the point where they're getting ready to graph it. I started the first one. We always put y over x, 6 over 2 equals 3. I want you to always practice this way and the graph, okay? If they ask you to do a graph, I want it both ways. So then I'm gonna go down to my next one, which would be 8 over 4, which actually equals what? 2. Then I have 10 over 6, which equals what? 1 and 4 6, which is actually 1 and 2/3. Can I stop right now? I can. Is this going to be proportional? No. 2 reasons why. Is there a constant? There's no constant, so I cannot make, I cannot do y equals k times x, right? And then does it go through 0? Now, I know this is going to be kind of hard to see with all of my other words up here. So if we look here, we're going to graph this. We go, this is my x, so I go over 2, up 6, over 2, up 6. Then I go over 4, up 8. Then I go over 6, up to 10. Am I on the right one? And then I go over 8 up to 12, right? And then it would be up there. Does this look like a straight line? It does, doesn't it? But if I continue my straight line, which I should have used a ruler, does it go through the origin? No. Okay? There will be coming time where you will know how to make this an equation from this. Okay, but right now we're not quite at that point. So let's look at 1b. Go ahead and just start graphing it on your little coordinate graph that I gave you. Once you're done graphing it, I want you to find the constant. There are no negatives, and so your little coordinate graph, can you just have it look like this little section here, right? All right, so if I need to graph these, I have the number of hot dogs. We always say this is X, this is my Y. So the number of hot dogs is 2, so I go over 2. Y is 6, so I go up to 6. I go over 12, which would be about here, and up to 4. Now on your coordinate graph, it doesn't have the numbers already there for you, correct? And I'm going 6, 12, 18, 24, 30. So what should I probably number each tick mark by? I could do 2s. Could I do 3s? Aren't these all multiples of 3? Yeah, so I'd probably do 3s. It doesn't matter. Okay? But my other So my x's I would do 2's, my y's I would do 3's, because you don't have to have them the same. Your x and your y can skip counting different numbers. You guys do realize that, correct? Okay. So is this going to go through the origin if I'm going down like this? No. But I still want you to see if you can find the constant by saying y over x. Y is 6, x is 2, so the constant here would be 3. Y is 12, x is 4, so the constant is 3. Ooh, are we getting a 18 is 6, 18 over 6, so that would be 3. Do we have a constant of proportionality?
Yes.
What's our constant going to be? 3.
Oh, so whenever you graphed it, you put the 12 as the x instead of the 4.
I said, is that what I did wrong?
Yeah.
Thank you. I should have gone 2. No, my x is 2.
Yeah, but you said the 12 was the x. You put the 12 as the x-axis and the 12 as the y.
I went over 2 up to 6, right?
Yeah.
Then I didn't go over 4 up to 12.
Yeah.
Thank you. You earned the candy today. I earned 5 push-ups. Okay. So if I keep drawing the line this way, is it going to go through the origin? It should. And it has a constant. And this is why we always do that, because I made a mistake. Then you write your y equals k times x. So then y equals 3 times x. Does that make sense? All right, let's move on. Go ahead and turn the page. So now they're wanting us to analyze. So basically it's just saying, what did we find out? What does it mean? So it says when two quantities are proportional, you can use a graph of the quantities to find the constant of proportionality and to analyze points on the graph. The graph of every proportional relationship passes through the point 0, 0. The point 1, comma, r tells you the constant of proportionality or the unit rate. We find the unit rate by y over x. Okay? And that's what we have just been doing. 1r, r would be your y, so whenever I go to the 1, what is my y? That's your unit rate. Sometimes it's not easy to find on a graph, so that's why we always want to represent it like this. So let's look at our second example. The length of the stretch in millimeters of a spring is proportional to the weight in grams attached to the end of the spring as shown in the graph. Find and interpret the constant of proportionality. Use the point 5, 25 on the graph. So I'm going over 5 up to 25. Notice that they're counting by ones on the x-axis, but what are they counting by on the y-axis? So remember, I just told you a minute ago, when you are making your graph, they don't have to be the same distance. They don't have to be the same numbers, as long as this is constantly going up by the same number, and so is this. So how do we find the constant? It's always y over x, which y is my 25 over 5, so my constant would be 5, correct? So 1, 5. The constant of proportionality or unit rate is 5 millimeters. What it means then to analyze this is to explain what the points 0, 0, 1, 5, and 525 represent. I am asking you, when you do today's assignment, that you do, when it asks you what does that mean, that you write it out in words. Okay? So it says the point 0, 0 represents the length of the stretch of the spring. 0 millimeters when no weight is attached. When 1 gram is, so to represent this one, I would say when 1 gram is attached, it stretches 5 millimeters. When 5 grams are attached, it stretches how far? 25 milliliters. So I'm going to give 2 examples with points, and then I'm going to say, I'm going to use my unit rate for every 5, for every pound, or not pound, excuse me, it's grams. For every gram, it stretches 5 millimeters. Do you guys understand how I would write that? Okay, because I want you to use a constant. So I would say for every gram, it goes 5 centimeters. Okay? But you have to also explain the 2 points, at least 2 points on the line. Well, here they tell us to do 3 points. So it says at the point 525 represents the length of the stretch of the spring, 25 millimeters when 5 grams weight is attached. I don't care if you flip those around. You can say when 5 grams weight is attached, it stretches 25. It doesn't matter to me. All right, so let's look at this example. Keith plants a seed. Every 3 days after the seed sprouts, he measures the height of the plant. The graph shows his results. Find and interpret the constant of proportionality. So you need to find 1 point. Later on, they're not going to give you the points on here. Okay? You're going to actually have to just look at the line and then find out exactly where they line up or where they cross at a point. Does that make sense? Like, I am not going to try to use 1 because 1's not here. Right? I'm not going to use, because this would be like 1.5, but that's, I don't know if that's exact 1.5, right? So find out where the lines, where the X and Y axis cross exactly. Okay, does that make sense? Okay, so then to find the constant of proportionality, what is my formula? K equals what? What is it? No, my constant. How do I find my constant? Y over X. You have to have that memorized. Constant equals Y over X. That is in our notes from yesterday. That's why today I went over it. I highlighted it. I said, this box is going to be the most important box that you're going to need to know. Okay? So to find my constant, it's Y over X. So I'm just going to pick this point here. Y is 6. X is 3. So my constant is 2. Check it with another one. Y is 12, X is 6, so my constant is 2. Does it go through the origin? Yes. So is this line proportional or non-proportional? Proportional. So it just says find and interpret the constant of proportionality. So here is my constant, which is 2. Right? So it goes, so for every 3 days, it goes up 6, the height goes up 6 millimeters, right? But now, to explain this, let's put it in our equation, which then this would be the Y equals K times X. So Y equals 2 times X. My X is my number of days, okay? So for each day, it goes up, how many? 2. So to write that out, you would say for each day, because if my constant is 2, that's like 2 over 1. 1 is my number of days, 2 is the number of millimeters. So for each day, my plant rises 2 millimeters. Then I have to explain the 1 and the 2. So on the first day, it goes up 2 millimeters. On the 6 days, on the 6th day, it goes up 12 millimeters. Does that make sense how you need to explain it? Okay. Does anybody have any questions so far? Okay, go ahead and you can stop. All right, so for